Hello there. I do have here two TV tuner, a digital TV tuner and an analog TV tuner. I'm using the digital one to receive the digital TV signal and the analog to receive FM radio. And I got a vacuum fluorescent display. I have borrowed it from an old device and I built a circuit for it. Two shift register. They are designed to drive vacuum fluorescent display and Arduino C microcontroller. And I use the Arduino Amiga to drive the multiplexer and the two TV tuner. And I got my remote control rotary encoder. And this is how I program this vacuum fluorescent display. This is all the connection. For the TV. And for the radio, go the green. Go change my oscillator frequency. I'm displaying this number is not the actual. I'm not displaying the station number. I'm displaying the frequency. I'm dividing. This is my oscillator. I'm using the second oscillator in the analog tuner because it has 3-band oscillator. And this is how I did the vacuum fluorescent display. This is the data. There's the number from 0 to 9 and then the alphabet character from ABC all the way to Z. And this display is where I got it from the old one. I got all here 14 digit. It's 5 by 7, 35 dot matrix. And I have 14 segment. And I got 1, 2, 3, 4 digit. And each digit has a 2 number. And all my grid. I number all my grid. I got 20 grid to control all of it. Plus all these Wi-Fi, Bluetooth and all these icons here and plus this digit right here. And here how I did decipher everything. And this is for the new one when I put it here in the pre-board. 2 shift register, one for segment and one for grid. This one for segment, all the segment, and this one for grid. I got 20 grid. This is the data. It's 32 bit each, the shift register. Each one of them is 32 bit. That create this all to decipher all what I need to display for each grid and for each segment. And I got 2 rows, the first row and the second row. And then I have to display it and then start sending it. I'm using SPI to send it. And I got my grid data right here. It's only 20 grid. And I'm using SPI 1 megahertz. It's good enough. Mode 3. Here is my grid data. And this is how I send the number to the display. This number right here. Of course. Now I'm gonna increment the channel for the. This is the 35 dot matrix. This is how I'm displaying the numbers. This is how I display the string and the number on the top. And of course I got all this data right here. This data and this data and this too, all in this microcontroller to control the 2 shift register. And then I'm receiving from the Arduino Mega over the I2C, send it to Arduino C to display. So I have to create I2C slave. And this is how I receive the data. I receive it, and this is how I display it. Receive it there. And for the master, this is how I receive it. I send it. This is how I send it, and this is how I receive it. Sort of, I receive it this way. This is how I receive it. And to send it, I have to build a library for it, and I call it Vacuum Fluorescent Display I2C Master. I did remirror my same method function, like display number in grade 15. I just remirrored in here and master. And an address. Every function I put an address for it. So I send it with an address and I receive it with an address. So there is no mix. And here I'm gonna send it. And I send a track too. So I don't go above the grids. Only I got 20 grids. And this is how I implement the I2C master. This is how I send 32-bit integer number. This is how I receive it. And now for the digital tuner and the analog tuner I made. So I'm using Vacuum Fluorescent Display I2C Master, the library I just did. And here how I send the data. I just mirror it. Set cursor and display Of course, if I put number, I will know that I want to display int. If I put string, you know, I want to put display string. And then for each grid, icons for each grid, I display it in order. It doesn't matter, not even in order, it doesn't matter. But as long as I put my track right, and display everything right. This is how I send it through over I2C. I start with the multiplexer, the I2C multiplexer first. I send it from Arduino Mega to Arduino C. Reference display. And this is for my remote control. This is how I use the function for the remote control. I assign each switch for a specific function. For instance, if I want to go back to TV now, the red button A, it will switch to square 1 here. Now I need to change my oscillator, and for the TV, digital TV, I go oscillator number 1. And then I go down in frequency, change my frequency. Now digital TV. If I go back to the analog tuner, I go number green 1B, I go change my oscillator, change my frequency. And here what I got for the digital TV is here how I send it for the oscillator number 1 or oscillator number 2. Oscillator 1 for the digital TV. I keep it changing the setting though. It got only 3, but I keep it changing the setting for low and high frequency, or ultra low or ultra high frequency. Same for the analog tuner too. I know which oscillator to catch up with signal. Like for the oscillator number 3 in an analog tuner, I can capture 950 megahertz, which is this transmitter right here. I can transmit 950 megahertz from this transmitter right here. So I got my Bluetooth, I got from my computer, and if I go here, if I come here, if I go oscillator number 3, I go up in frequency, and I'm locked. I'm locked. That's for oscillator number 3 in the analog tuner. And the data sheet for the analog tuner, that's the digital, I believe. Oh, this is the shift register for the vacuum fluorescent display. It's capable of driving the fluorescent. I'm driving it through 30 volt right now. Oh, 30 volt. cable of switching capability 60 volts, so it was easy to use it, the shift register to drive the freaking fluorescent display. This is how I figured out the TV tuner from the service manual. Well, I got a screenshot for it. So I'm going to go through all this. This is the analog tuner. So I'm using the high reference and the high mixer, the ultra high, and the ultra high oscillator to capture the signal coming from the Sony transmitter. So I'm receiving Bluetooth from my computer. Here's the transmitter Bluetooth. I'm receiving it 2.4 gigahertz. I transmit it back to 915 megahertz, and I receive it through the analog tuner. And if I just go back to FM, all I do is just go oscillator number 2 down in frequency. Display number 3, oscillator number 3, and I'm locked back to 915 megahertz. Here's the tuner. I bought it off from an old TV, and I bought it in pre-board, and I did name everything. This is how I shift the analog tuner. This is how I shift that. So I'm oscillator number 3. So this is how I divide my frequency. Programmable divider. As my TV still on. Let's go try to go different channel TV. TV. Now you need to go down oscillator number 1, down in frequency. I believe I need to go up all the way up, because I need to go step not by 1. I need to go higher than that. Anyway, let's keep going. Cliff 296. What's wrong with digital TV? I'm not dividing right.
Advanced formula has prostafat, 3 key ingredients to
I'm only controlling digital TV only through to I2C,
in one. That's why it's a best
and the rest of the information is going to the board
to urinate.
where I got it from the TV box.
Recommended most.
I'm only dividing the signal through the phase lock loop. But for the analog tuner, it was easy to divide. I go oscillator number 3, Apple frequency. This is my audio amplifier. I control it through Arduino Nano too. I got it from old cassette. It's a very good amplifier. I will put the wire diagram and more explanation in the description. Thank you for watching. That's my clock. This is my clock right here. The clock. But it's not working yet.